Hello programmers, I hope you're doing well. Today I would like to talk about AOT compilers. First of all, let me introduce myself if you don't know me already. My name is Eitan. I'm a full-stack JavaScript developer. I do that for a living and I do that for fun. Nothing really special over there. And when it comes to programming, I really like to focus on things which are trivial. Okay, so take something which is part of our daily routine as programmers and really dive deeply into it and understand the core of it and how it really works. So naturally, it's low level, so that means that it's not necessarily going to turn you into better React or Angular developer, but it does going to turn you into a better developer in general, because this information that I'm going to provide you with is going to help you solve problems that you didn't know that you could even solve this way. Many edge cases that a lot of programmers don't know how to solve, and simply a new world of possibilities will open up to you. Okay, you could do things that you didn't know that you could even do. And this is why it's such an interesting subject, okay? Yeah, so AOT compilers, AOT are initials for ahead of time, okay? Any kind of transformation that we apply on code before we actually run it. Example compilers are compilers for C or C++, where we compile it into machine language, or in the case of the JavaScript ecosystem, we compile ESNext, which means ES 2015 and above, to ES5. And why is it such a trivial topic? Because nowadays, in the JavaScript ecosystem, I think all of us, we use Babel to compile ESNext to ES5, or we use TypeScript to have type safety, or we use JSX. We never use ES5, even though essentially the application are being compiled to ES5. And no one ever wonders how this thing works behind the scenes and what you could actually do with that. So I would like to explain about why do we use a compiler when we write JavaScript applications. I'll start with very trivial things. Later on, I'm going to dive deeply into how it works and how you can write plugins into the compiler. So just bear with me. All the information that I'm going to provide you with is going to be in relation to Babel's API, because it's a very popular compiler in the JavaScript ecosystem. Okay, but the rules apply, I believe, to all compilers. Okay, they all work on the same fundamentals. So this information is quite useful for other languages. Let's start then. Why exactly do we use AOT compilers? First of all, we can optimize the code before we actually run it. For example, tree shaking. So if there are modules that we import and we are not planning to use them, we can just get rid of them. Or if there's allocations and lines of code that are not actually going to affect the program, then we can remove them. Therefore, we can save some memory and solve maybe potential memory leaks. Also, the compiler throws errors ahead of time. So, for example, when we use a linter or we use TypeScript, we know that there's something wrong with the code. Maybe there's a piece of code that we are not using. So the compiler is going to say, hey, here's the problem. Fix that and try again. And later on, let's see if I can actually compile the code. So this is an advantage before. So you discover problems before you actually encounter them during runtime. Also, it enables backward compatibility. So right now, if I'll open the browser, let's say I'll open Chrome DevTools and I'll try to type arrow functions or async await or generators or whatnot, it will all work. But we don't know what browser the client's gonna run. Okay, the client can run a very old browser, such as Internet Explorer 10. So Internet Explorer 10 doesn't support many of the modern features. So what we want to do, we basically want to reduce the number of features that we use in our applications when it comes to JavaScript, okay? So we can use the most advanced features, and later on we can compile it into an older version of JavaScript, and therefore we can run it on many types of browsers. Also, when someone suggests a new feature for the set of specifications for ECMAScript, it takes time before this feature for the syntax gets approved. The committee needs to discuss about it, the community needs to accept it, and see how it works well within the language. It needs to go through stage 0, 1, 2, 3, maybe 4, I'm not sure about that, not very important. And once they officially accept it, then all the browsers need to make sure that they implement that in a native language in C++, and this entire process takes time, okay? So first of all, it's relatively easy if we have like a compiler that is written in a higher level language. It's easy to implement plugins, okay, because we write it in JavaScript, so it's relatively easy, it's faster, and also we get the opportunity to test the new features and know if it actually works. So this is definitely helpful. We can also use custom syntax, which is not part of any specifications. Even though we use JavaScript, we can apply something on top of it, such as Flow or TypeScript for type safety, or we can use JSX to create, to implement React apps very easily. So yeah, definitely there are advantages over there. So now I would like to talk about the stages of the compilation. Okay, essentially it splits into two stages. Stage 1, we take a code string and we parse it into a JSON representation, into a tree representation, not necessarily JSON. This tree is made out of nodes, which are nested in one another, and each node represents a feature in the syntax of the code. Okay? This tree is called AST, Abstract Syntax Tree. And with this tree, it's very easy to later on generate another language out of the source code. Okay? And this is where stage 2 comes in, the generation process. We take the tree, and then from, let's say, ES next, we can compile it into ES5 or machine code, or it doesn't matter what code. It's very easy to do so once we have a tree representation of it. So I just put this information out there in a very general way. I'm sure that it's not very clear right now, but let's start with stage 1, and I'll try to explain it a little bit better by demonstrating it. Okay, what exactly does an AST means? So for that, I would like to go into a website. This website is called AST Explorer. It's a really nice website because you have two windows. On the left, you have a window where you can type code. On the right, you can see the AST that represents the code. Okay, and it supports many syntaxes such as CSS, GraphQL, HTML, JSON, Markdown, PHP, anything which is web related. And also there's different parsers that it can use. By default, it uses Babylon 7, although there are many parsers for JavaScript, such as Acorn or Esprima or TypeScript. Acorn and Esprima had a significant part of the history of the JavaScript parser. Right now, Babel merged Babylon into the official monorepo of Babel, so it's called Babel parser, but it's still very much relevant. Okay, so I'm going to use Babylon 7, and look what happens once I type some code on the left window. Okay. So this is just plain JavaScript, ES6. Okay, so I type the code over there, and you see that the window on the right gets updated. So what's nice about this website also is that I can highlight something on the left, and then it will highlight it on the right as well, and vice versa. So I can put the cursor on top of any node that I would like to select. I simply hover over it, and then it will highlight it on the left. So it's very easy to analyze the code and compare the AST to the feature that it represents. So if we'll take, for example, we'll highlight this, number 1, and we'll go to the node that represents it. We see that the type of the node is numerical literal. It describes the syntax that it represents. And also it contains the value 1. So you see it's actually JavaScript only in JSON. So now that we understand what's an AST, I hope, how exactly do we take code and we parse it in a Node.js application? Okay, again, I think I mentioned it at the beginning. Everything that I'm going to talk about is going to be in relation to Babel's API because it's very popular in the JavaScript ecosystem. Therefore, I would like to go into their documentation website and show you how exactly the API looks like, because it's important for me to back up the things that I say and show you some proofs. So there's a library called Babel Parser, and the API is fairly simple. We import the parser. The first argument is going to be the code string, and I would like also to talk about the options. Of course, there are many options that it can accept, but the ones that I would like to focus on are these, the features that you would like the parser to parse. Not all syntax features are yet officially part of the ECMAScript set of specifications, okay? We have things that are still in beta, such as async generators, decorators, do expressions, function bind, things that I'm not even familiar with, to be honest. So you can specify what syntax you would like to be able to parse. Also, additionally to that, there's language extensions. So you can parse Flow, JSX. TypeScript, yes, it can parse TypeScript partially, not everything. TypeScript actually has a dedicated parser for it and a dedicated compiler, but it's still a nice thing to have that it supports it. Anyways, I would like to show you an example and how exactly you import it in a Node.js application and how exactly you work with it. So I wrote a demo for that. Okay, let me just make it bigger. Okay. So we import the library. We provide it as with a code string, as I already mentioned. And what I do here, I just print it to the console. Okay, the AST. Now let's run the application. I'll just go to the right directory. And I'll run the program. And as you can see, we have the AST printed. Now I'm not gonna analyze the AST because this is very boring and I think you got the principle. It's the same thing that we saw in AST Explorer. Now, going to the second stage, generate. So once we have the AST, it's very easy to generate another type of code out of it. Okay? So first I want to look again at the Babel documentation website, and later on I would like to demonstrate. This way things would be much clearer. Okay, so there's a library called Babel generator. Let's look at the API. Very simple. After we parse the code and we get the AST, we can generate it back into other type of code string. Okay, the first argument is going to be the AST. And I would like to demonstrate it, so I'll just check out the right branch. Check out generate. Okay, let's look at the example. So once we parse it, we use the generate function that we imported. We provide it with an AST and we print the code. Now the expected output should be exactly the same. And let's run the program and see what the output is. As you can see, it is exactly the same. It is exactly the same as expected. Only there are semicolons. This is because the AST doesn't contain information about semicolons, but functionally speaking, if I would run this program, it would be exactly the same as this program. It's exactly the same. Now, going back to the slides, I would like to add another stage, which is optional, but very important to know of. This is by far the most complex stage because this is API specific. Right here, after stage 1 and before stage 2. This is called manipulation. Okay, and this is a very powerful concept. Why? Because with manipulation, okay, once we have the tree, we can manipulate it and therefore transform the code the way we want before we actually run it. And using that, we can improve the user experience and we can optimize the code. We can do things like tree shaking if we do the manipulation correctly. Sometimes it's not easy to do so. And so I would like to demonstrate it as well. Okay, so once we have the AST, we can manipulate it. Let's say that using that methodology, I would like to change C into B. So I would have here something like const B equals 2. So what do I do exactly? I address the right node that represents this code over here, and I would change the right value from C to B. And here I have the path for the node. Now, how exactly did I know which path to address? Very simple. I copy the code that I would like to manipulate. I go back to the browser into AST Explorer. I paste it over here. And then I highlight the thing that I would like to change. I would like to change C to B, okay? It is being highlighted for me by AST Explorer here on the right. And then I go back to the root. Okay, and I write down the path. So it starts from root, program, body at position 0, declarations at position 0, ID, and there we have it named C. Let's say that I wrote everything down. I go back to the program, I paste it over here, and then I reassign it with a new value. Now, because we manipulate the AST and we put it back into code, the expected result should be something like this. Okay? Let's keep the original code and run the program again. And as you can see, the code has been transformed as expected. There is one problem with that approach, however. What I do over here is very specific into a specific code snippet. Okay, we need some sort of a general pattern that can apply itself on a code string and therefore generate it automatically based on a set of conditions. Based on a set of conditions, basically. So how exactly do I do that? Again, once I demonstrate it, I believe it will be much clearer. Okay, we need a more automatic way of doing so because this thing over here is tedious and it cannot apply to any code string. No way. So a lot of compilers, what they do, they provide a way, an API to manipulate the AST, okay, rather than doing that manually. So usually, what you would be able to do with the compilers before they generate code from the AST, you would be able to walk through the AST, okay, go through each and every node, and based on a set of callbacks that you define, the code will be manipulated. Okay? These set of callbacks that are contained within an object are called, this entire object is called a visitor, because it visits the tree once you walk through it. You can call it walk or run or traverse in the case of Babel. So again, let's go to the documentation website and let's look for the right library. Babel traverse. So we import the traverse function, and the first argument is going to be the AST. The second argument is going to be the visitor, which is going to manipulate the AST. Each key within the visitor object matches the type name of the node that it would like to manipulate. The first argument, it contains different kind of helpers that would help us manipulate the tree. But right now, because I would like to keep things very simple, let's focus on that, on the node. Okay, so it contains the node, and we can change it via the callback. So I would like to demonstrate it, again, using a Node.js application. So what I'm going to do now, I'm going to check out the right tree. Manipulate, I believe, yeah. Let's look at the demo. Okay, so it's exactly the same thing. We have the same source code, and we also have, we use the generation function to generate another code out of the source code. But in the middle, we use the traverse function to traverse through the tree and manipulate it. Now, you see that I defined here a couple of callbacks. Variable declarator and function declaration. So the expected output that I would like to have based on a general pattern that I'm going to apply using a manipulation visitor. Let's write it over here, output. It's going to be something like that. Let's say that all the const assignments I would like to change from C to B, all of them. I would like to change all the numeric literals from whatever it is to 2, and all the function names to fn2. This is the expected output. All right, this is the expected output. You see over here, this is exactly what I'm doing. Exactly what I'm doing. Now, how did I know what to write as the callback names? How did I know the type name of the nodes? Again, I'm going back to AST Explorer. This is a very powerful tool exactly because of that. To make things simple, I'm going to copy the source code that we would like to parse. Wait. Then I highlight the node that I would like to manipulate, and then it will be highlighted on the right, and here you can see the type name. I just copy the type name. I know this is the matching type name, and I paste it over here. I also address some properties within the node. How exactly did I know which properties to address? Again, we look at the AST and we see what properties does the node contain. Very easy, very simple. Okay, these are the fundamentals of the visitor. Now, if I will run the program, you will see that this should be the output. Okay, let's just run the program. Okay. See? Exactly as I said so. Now, rather than explicitly redefining the compilation logic, and then trying to accumulate visitors that are going to um, manipulate the tree. Babel made it easy for us, and so do many other compilers. What they do, they basically have a mechanism of plugins. Plugins are responsible for manipulating the AST just like that. So what a plugin is, it's simply a visitor. This is all, it's all about the visitor. Okay? So I also prepared an example that can demonstrate that. Here I have an example that takes an input. It's exactly the same input as we had before. The output doesn't exist yet. The expected output should be exactly the same as we had over here. Okay? And you can also write a plugin. Okay? In the case of Babel's API, this is how it should look like. It accepts more arguments. Okay, but essentially, I would like to focus only on the visitor because this is the main thing here. I just want to keep things simple. Later on, you can look at the Babel documentation website. I also provide you with a really nice handbook that I recommend you to read. But for now, just focus on the visitor. This is what it's all about. And what Babel does, it looks at the node modules, at the names that you specified at the Babel RC file, and then it basically grabs, it fetches all the plugins, and the plugins are simply visitors. Now, if we will run this program, let's go to the program, plugin test, and we will run it. We'll go now to the output file, and we see that is exactly the same. Because, again, plugins are visitors. Okay, so there's no surprises here. Why exactly this information is so useful? How can you take advantage of that? Us, as developers, the first thing that they teach us is how to make the manipulation themselves and apply all the logic at runtime. This approach is not many times, but there are some times that it can be problematic. And ahead of time compilation can really make the user experience so much more comfortable and save some processing power that there's no need to do everything on runtime. Okay, and this is exactly the point. Now, I would like to show you a couple of examples of plugins for Babel that I wrote. You don't necessarily have to agree with what they do and what they achieve exactly, but I would like you to focus on the context, the things that are possible to do using the knowledge that I just provided you with. Okay, so let's look at that. So this is a plugin for React. If you're familiar with the new hooks API, you would know that we have hooks such as use memo and use callback that basically prevent logic from rerunning once we re-enter the render function. Okay, so over here, rather than refiltering and sorting and just preparing the data, we need to wrap it with use memo so we can cache the calculation. Okay, so this plugin will automatically look inside the function's body, and based on the logic, it will call use memo automatically with the right arguments. It just looks inside. This is how it does that. And even if we have anonymous event handlers, it will wrap it with use callback with the right arguments. So this is the first plugin example. This is very useful because it can save a lot of human errors. Okay, and you don't even need to think about it once you just develop your app, your React app. Next example. This is something with styled components. So with styled components, again, you don't have to agree with that. I know many people didn't like this concept, but still, it's achievable using Babel plugins. If you would like to encapsulate the style of a certain component, let's say we have a dashboard, then you would need to create a dedicated child component per style that you would like to encapsulate. With a plugin that I wrote, you can specify a single style component that would use private class name prefixes. Okay, so you simply add an underscore before the class name, and then the output should be an automatically prefixed class name. Okay, so it changes the way you use styled components. Again, you don't have to agree with that, but still, it can show you that you can significantly change the user experience using plugins. Now, before I finish up, I would like to recommend you a handbook that I would like you to look at. So you can look for it on Google. And this is the handbook, okay? I know that there's not, the documentation for writing plugins for Babel is not, how can I say that? It's not the best out there, okay? But I try to provide you with as many information as I can, make it as clear as possible, and also provide you with all the right resources. So this is a very important resource that you can use. You can read more about the visitor, the arguments that it gets. So there's this one, AST Explorer. AST Explorer, the Babel documentation website. You can also look at the plugins that I wrote. You just go to GitHub, to my username. Everything, you can see it over here. You can just browse my profile. And you can also look at the talk that I just recorded. This can help you significantly. Anyways, I hope you liked it. If you have any further questions, feel free to leave a comment. Subscribe if you feel like the video. I'll see you in the next video.